Hello everyone and welcome back to Crayon Code. As indicated last time, today we're going to take a look at iteration protocols and what makes for of work in JavaScript. So what I want to make work today is basically this. I have initialized a doubly linked list with 4 items, and now I want to iterate over that list by using for of. And now to make this work, we have to first implement the so-called iterable protocol. And what we need for that is a function which is accessible through the iterator symbol. So whenever the right-hand expression of is evaluated, it is checked if that object implements a property that is accessible via the symbol.iterator and if it's actually a function that's required. And now what does this function do? This function needs to return an iterator. An iterator is a special object which has exactly one method, which is called next, and it does not take any parameters. And the next function is required to have a special behavior, which we are going to implement now. So let's see. I want to implement an iterator that moves forward in the list from the beginning on. So we need a variable where we can track at which position we're currently on, and naturally, since we want to start from the beginning of the list, we initialize it with this.head. And now, every time next is called, we advance in the list one item forward, which means that we first need to get the value and the next item from our current item, and we need to advance to the next item. And now the iterator needs to return an object. And this object contains on one hand the value of the current iteration and a property called done, which is in this case false, because we assume we are not at the end of the list. So by this property, we tell the caller of the iterator that the list has not ended yet. And now what happens if next is null? Because if we have reached the last item, next is null, and this is not covered yet, because if we try to destructure value next from null, of course this will give us an error naturally, and in order to prevent this, we first check if current is not set anymore. And if this is actually the case, we need to let the caller of the iterator know that the iterator has reached the end. So we simply return another object that has done set to true. And in that case, value does not have to be given in the object, so we can simply omit that. And now if we test that, let's just see, because what we expect now in the console perfectly well is ABCD, which is exactly what we have put into the list in the very beginning. And now let's do something special, because with this way, it's very simple to implement an iterator which starts at the end and works its way to the first item. And for this, we're going to implement a function which is called reverse. And this function returns an object which also implements the iterable protocol, which means that we return an object which also has a property which is accessible through the iterator symbol. And of course, this property is a function. And from now on, it basically repeats, because this function needs to return an iterator object. And as we know that the iterator object needs to have exactly one function called next, which does not take any parameters. And we do basically the very same thing, just the other way around, which means that when we start the iterator, we have a current position. We get the current position in this variable, and we start not at the head, but at the tail. So, and of course, we again destructure value, and this time not next, but previous from the current position. And now we do not advance forward, but backward, which means that current will become the previous item. And of course, we again need to return an object telling the caller the actual value and if the iterator is done or not. So, and of course, we also need to get this covered if we have reached the end of the list, or at this moment, it's the beginning. So the first item, we cannot advance more forward. So we return again an object, which tells the caller that the iterator is done. And now this is actually cool because if we do something like this, sorry, that is what's wrong. So now we still can use this in the for of, but in this time we do not pass the list itself to the for of, but the result of the reverse function, which means that whenever reverse is called, it returns a new object which contains a property which is accessible through the iterator symbol. And this is exactly what for of needs. It doesn't need just an arbitrary object which has this one property with a parameterless function which behaves exactly that way, that it has a next function returning an iterator object, basically. So, and what we now do is the very same thing. Here we log out the items, and what we can now expect is ABCD from this for of, then reverse, and then DCBA. And now if we check this, we can see that it doesn't work. Because I think I made a mistake. Yeah, exactly. Because I did not use an arrow function here, which means that this context is not given anymore, or not properly given, which means that tail is undefined. And since tail is undefined, we will simply enter that if block. So in order to get this covered, we make this an arrow function which automatically captures this context from the outerlying scope. So I guess this time that actually should work. Perfect. You can see here first ABCD, then reverse, and then DCBA. So to wrap this up, in order to be able to use an object with the for of loop, you have to simply implement two protocols. One is the iterable protocol, which means that the object to be iterated through needs to have a property which contains a function and is accessible through the symbol.iterator symbol. And this function needs to return a specific object. And this is now where the so-called iterator protocol comes into play, because this object that is returned from that function needs to return an iterator object, which means that it has exactly one function called next. It does not take any parameters, and it always returns an object. And this object must anyways tell if the iterator is done with done true or false, and the current iteration's value. And if the iterator is done, the value does not have to be given. I hope you enjoyed this episode of Crayon Code. Stay tuned for the next one, which is going to be about generators. And if you don't want to miss out on that, just hit the subscribe button.